picking up the Bible and saying, you know, like we said at the beginning there, because I said so. These are the kinds of things that scientists are looking at and they're saying, wow, that sort of smacks of intentionality.
Right. Well, maybe if it's okay if you had like 1 or 2 or 3 of these things, but there's dozens of them.
Okay, so let's come even closer to home. Let's get in our solar system. Now we're here with, what, 7 or 8 planets?
Yeah, the solar system is interesting. Like the Earth's distance from the sun is just the right distance, because if it was any closer, just a fraction closer, then it would be too hot and everything would kind of boil off. If it was too farther away, it would be too cold and everything would be frozen and unable to support complex life at least. And also, the orbit of the Earth is nearly circular. It's not exactly circular, it's somewhat elliptical, but it's nearly circular, which is unlike most of the other planets, which
most of the other planets are more
elliptical.
Okay. Yeah.
And so, if the Earth was more elliptical like that, you would get extremes in temperature variation.
Too far away from the sun, too close to the sun.
Yeah. Right. And the moon is also the right size and distance from the Earth. If the moon was more massive, for example, you would get massive tidal action that would cover large portions of continents.
Because the tides are caused by the moon.
Right.
And if the moon had bigger mass or was closer, then we would have these
massive tidal actions.
Okay.
And if the moon was too far away, you wouldn't have enough tidal action to stir up the oceans to keep it well oxygenated. It would become stale, stagnant, and everything would die.
Now, you had told me one time, this is quite fascinating, C.A., he had told me one time about the color of the sun.
Yeah, the color of the sun is also interesting, because if it was redder or bluer, photosynthesis wouldn't work as well.
Or maybe not at all, perhaps.
Or maybe not at all.
So this does give emphasis to your point that it seems as though the universe was made for man to inhabit it, that these things were ordered just as they needed to be so that we could live.
Yes, and it even goes down further, like to the atomic level.
So now we're going really small.
Right. Yeah, because the atom is quite a sizable bundle of nice coincidences, if you want to coincidences. For example, the size of the electron versus the proton, for example, are very different, almost 2,000 times more massive, the proton versus the electron.
The electron's just the little one.
This tiny little thing flying around the nucleus, right?
And it's 2,000 times smaller.
Almost like 1,836 or something like that.
Smaller than the proton.
Than the proton.
Okay.
But the charge is exactly the same. In counterbalance, the opposite charges, but the same
electron positive,
same degree.
Electron negative, proton positive.
Versus, the same degree of charge. Whoa. And that's very interesting, because there's numerous parameters between the proton and electron. None of them are the same, except for the charge is exactly the same.
Really?
If it was any different to any significant, well, any small degree, there would complex molecules would not develop, would not be able.
Because you wouldn't have a stability.
Right.
Yeah.
Fascinating.
And also the same thing with the mass. The ratio of mass between proton and electron, if that were slightly different, also complex molecules could not develop.
So it's not just an issue of the charge, it's the mass.
Right. All these parameters have to be like they are.
Exactly like they are.
Right.
And so these are the things that physicists look at, physicists like Paul Davies. I think we've got a quotation here from
it's very interesting.
Paul Davies.
Paul Davies, in specific, he kind of points out that physicists, even more than biologists, believe in at least some sort of higher power behind it all. If you call it God or whatever it is, some sort of intelligence. He's an Australian astrophysicist, pretty well known. He writes, Schutz's stunning accuracy in the precisely balanced universe needed to support complex life is surely one of the great mysteries of cosmology. The belief that there is something behind it all is one that I personally share with, I suspect, a majority of physicists. That there must be a God, he actually calls him God, who is responsible for these laws and responsible for the universe.
Fascinating.
Yeah, which says to me, if you delve into these subjects with an open, unjaundiced eye, the evidence will lead to, at the very least, a designer. Some sort of order and some sort of intelligence.
A lot of people,
named it.
A lot of people complain about that. You know, you're talking about a theistic sort of being, but it's not necessarily Christian. You're kind of undermining Christianity, but I don't think so. I think understanding that there is at least a designer is a first step toward God.
Absolutely.
Yeah.
So,
so Davies is saying...
Davies is not by himself. He says there's a majority of physicists, as far as he knows. And here's another one, for example. We won't go through a lot of them here, but just another one. Owen Gingerich, he's a former professor of astronomy from Harvard. He writes, to me, belief in a final cause, a creator God, gives coherent understanding of why the universe seems so congenially designed for the existence of intelligent, self-reflective life. It would take only small changes in numerous physical constants to render the universe uninhabitable. Somehow, in the words of Freeman Dyson, this is a universe that knew we were coming.
All right, I love it.
Ooh, I
love the term, David, congenially designed.
Yeah, you picked up on that too. I'm so glad you picked up on that.
God put it together, and if you change any of 1,000 variables, we could not be. Right. It was all perfectly done for us.
From the big things all the way up, the universe, galaxy, solar system, planet Earth, even down to the atomic level.
Yeah, and by after a while, you start asking, what are the odds that these just happened?
If I'm not mistaken, Davies has written a book. I've got one of his books, Cosmic Jackpot, but he's written another book, I think, called Goldilocks Universe or something.
A lot of these are related to gambling, good or bad, because, what are the odds? If someone starts drawing aces on you for every hand, pretty soon you're going to be wondering, hey, maybe this guy's is deliberately cheating here, And the same thing with the universe. Maybe the universe is deliberately set up to be like this.
Like it says there, this is a universe that knew we were coming. Right. So, okay, so we asked the question, why believe in a creation at all? You've given us sort of two answers here, or we've given the two answers. We've all been interacting here. And the first is, well, first of all, the appropriateness of the language of physics and mathematics to describe the universe, that there are minds here to get it.
Right, and that we can understand that.
And the second is that there are these anthropic principles that sort of scream designer, intentionality, God, and these are not the conclusions of Bible study. Physicists aren't saying, now what does it say there in Ecclesiastes? They're looking through telescopes.
Yeah.
Right.
Okay.
And a lot of them are opposed naturally to theology or any religious implications. Some of them are forced against their will to this conclusion.
Yeah.
Some of them don't like it.
Right. In fact, a lot of them don't like it.
But they're following the classic dictum to go where the evidence leads.
Right.
Yeah.
Okay, so now let's move to our next question. Let's transition, which is sort of, okay, so now we've got God or a designer, but what we believe, what CA believes, what I believe, what you believe, probably what many of our viewers believe, is a literal 6-day creation.
Yeah.
God said it, I believe it, that settles it kind of a thing. So, but that's just a matter of faith, right? There's no scientific evidence for that.
Well, if that was true, I mean...
I'll set him up.
If there's no real scientific evidence for your faith, when we're told to provide a reason for your belief, if I asked you why you have faith, what would be your reason? For me? Some people would say, I've asked this of a lot of people, some people say because I feel it. I feel that God has spoken to me, I feel this impression, this deep impression. But to be honest with you, I've never felt this. I've never felt this God speaking to me, this deep impression. I haven't had an angel talk to me. So what do I have to give me any confidence in God? And those like me who have never had divine revelation in such a direct way. I'm not discounting it. I'm just saying there are a lot of people like myself who've never experienced such direct revelation.
Got it.
And so for those of us like myself, I think there is abundant evidence in nature, beyond the anthropic principle, to believe in the, not only that the biblical authors intended to write a literal narrative of real events in history, but that this literal narrative has good evidence in nature.
So let me just make sure I'm understanding you. You're saying that what the Bible says about the origin of the world and of course the flood, the catastrophe that took place, that there is scientific evidence to sort of support this.
Right.
Okay.
At least, I mean, for example, Seventh-day Adventists believe, as a church organization anyway, that creation took place in 6 literal days. Well,
I believe that.
If I go outside, you say, well, prove it to me, right? Well, here, let's say, oh yeah, okay, go ahead and prove it outside of the Bible. I can't actually prove it to you that it's 6 literal days, but I can show you a lot of things that scream catastrophe and short chronology.
So what are some of those things?
At least much shorter than mainstream geology.
What are, and we could talk about the theology, CA, but that's really not the purpose of the program. We could say, what are the biblical reasons for believing that that's what Moses intended to communicate? And I think we're taking Moses at face value. I think we're taking Jesus at face value. He obviously endorsed the Mosaic scriptures and account.
Surely.
So I think we can sort of have that as a bottom line, at least here.
Yeah, at least here for us. But it's not just us, too. Even secular scholars, Hebrew scholars at well-known universities, secular universities, will support us on this one.
Yeah, you shared a quotation with me. I think you have it with you one time from John Barr.
James Barr.
James Barr, who's sort of a renowned Hebrew scholar.
Right.
And he basically says, it's obvious. Why don't you read it to us?
Yeah, let's. Yeah, James Barr, a late professor of Hebrew from Oxford, he writes a very interesting statement, I think. He says, probably, so far as I know, there is no professor of Hebrew or Old Testament studies at any world-class university who does not believe that the writers of Genesis 1 through 11 intended to convey to their readers the ideas that, number one, creation took place in a series of 6 days, which are the same as the 24 hours we now experience. And number two, Noah's flood was understood to be worldwide and extinguish all human and animal life except for those on the ark. Or, to put it negatively, the apologetic arguments which suppose the days of creation to be long eras of time, the figures of years not to be chronological, and the flood to be taken merely as a local Mesopotamian flood, are not taken seriously by any such professors as far as I know.
Mm.
Whoa.
Yeah, powerful.
In other words,
so there you have it.
And
Yeah.
he doesn't necessarily believe that Genesis account is correct. He just believes that the authors of the Genesis account intended to convey a literal account of historical events. He just thinks that they're wrong, which is much different.
Which makes it even more profound that he's saying that.
Precisely, yeah, yeah. So that if you come up with 6 indeterminate periods of time, that cannot be defended from the Scripture.
From the text.
Because those guys are trying to tell you 6 literal days.
Yeah.
So if you come up with anything else, that's doing violence to what they're trying to say.
You nailed it.
For the intent of the author.
Precisely.
It's different to say, well, the author intended to say this and he's just wrong.
Yeah.
That's a whole different
Argument.
scenario.
It is, yeah.
Right.
Mm-hmm.
Okay. So then what are some of those? You said there are some things that scream catastrophe and scream young Earth.
Right.
Okay, so do a little screaming.
Scream away.
Scream away.
All right. Let's say you go out to a mountain range, or like the Grand Canyon is a classic example, and you look at
I think we've got a picture of that. Of course,
yes,
many have seen that.
We do have a picture of the Grand Canyon. Here we have sedimentary layers, sedimentary rock. Everybody believes that this rock is laid down by water. The challenge is that most mainstream geologists believe it was laid down over vast periods of time, and that there's gaps in time between each of these layers that are millions of years.
Okay.
But the problem, if you consider this, is that if each layer represented the surface of the ground for millions of years of time, you have to ask yourself, well, where is the erosion, the evidence of erosion, where you would expect to see gouged out places and unevenness generally throughout.
Mm-hmm.
And beyond this, Arthur Chadwick from Southwestern, he's doing studies on what's called bioturbation, where burrowing... Bioturbation.
Okay.
Bioturbation.
I was just reading a book on that.
Yeah.
Sure you were.
I didn't get that one.
Oh, it's classic.
What is bioturbation?
There we go. There we go.
Thank you.
That's where I was headed. That's where I was headed.
David's reading notwithstanding. Yeah.
Yeah.
What are we talking about?
It's essentially where burrowing creatures go in and churn up the ground.
Ah.
Any creature that
Like my kids.
Exactly.
Okay. Okay.
So usually over the course of a year or two, burrowing creatures will go and churn up the ground after a deposit of flood sediments and mess up the layers so that you will not be able to recognize the layers anymore after about a year or two. Well, according to Arthur Chadwick and others researching this, within the fossil record and geologic column, bioturbation is minimal at best. It's very minimal. It's not what you would expect if these layers really represent vast periods of time.
Millions and millions of years.
Right, because the layers are so crisp and well-defined. And they're so flat for over such vast
you
areas.
have mammals, you have mollusks and things that are sort of digging in the sediment, mixing it up. But when we see, for example, that picture there of the Grand Canyon, it's just these it's almost like they're cut with a laser.
Yeah.
I was just at the Grand Canyon, and it's just...
Yeah, they're so precise and
So where's the erosion? Where's the undulations? Because the surface of the Earth today, we just drove here. We're here in southern Illinois. Where's that at?
Evidently, the world was a very, very flat place for a very long time, and it never eroded.
A flat Earth. Okay.
So yeah, that's...
And so what's our explanation of that? What's the biblical explanation?
Well, it seems much more consistent that these layers were laid down by water rapidly, one on top of the other, either by a series of rapid catastrophic events that were closely spaced, so close together that these digging creatures didn't have time to mess up the layers, and that there was no time for erosion between the layers to any significant degree.
Okay, so it just looks like what you'd call, say, rapid deposition, that it was laid down, it was flat, you don't have time for an undulation or unevenness, another's laid down. So it looks rapid deposition.
For example, if before the flood, there were no really high mountain ranges to block any sort of tidal action worldwide, and if the whole world was covered by water, you could get massive tidal waves, 2,000 feet tall, traveling at the speed of sound, for example. And what's going to stop them if there's no massive mountain ranges? They'll go around and around, and every time they go around, they're going to lay down another layer of sediment. It's not like I can explain all the features of the geologic column or the fossil record, but those particular features seem to fit better with a flood model, or at least a catastrophic model of shortly spaced catastrophes.
Okay, now you've mentioned erosion there a couple times. I'm a rock climber. I love climbing. I know you're into that too, CA.
That would be no.
But let's just say that I wanted to go to Mount Everest. And I've climbed to the top of Mount Everest, which isn't really a climb, it's more of a hike where there is no oxygen. And I get to the top of Mount Everest and I begin to dig down through the snow, so to speak. What would I find there? What kind of rock am I encountering at the top of Mount Everest, the tallest mountain on the planet?
You didn't count sedimentary rock on the top of Mount Everest.
The same kind of rock that we see there in the Grand Canyon. This
yes, exactly
laid down by water. What's it doing up there?
Yeah.
Well, when the Indian subcontinent crashed into the Asian continent, it built the Himalayan mountains.
Yeah, okay.
And so those mountains used to be flat and covered by water, or at least the sediment was deposited by water, and then when they were pushed up...
So they're sort of pushed together?
They pushed up, and then the sedimentary rock warped up on top of them.
Well, here's my question, good doctor. Scientists see this sedimentary rock on the top of the tallest mountain in the world. How do they explain that?
They explain it the same way. They say, yes, it was originally flat and laid down by water, and then they got pushed up. But they just say it was pushed up 50 million years ago.
Okay.
But then the question is, if it was pushed up 50 million years ago, why is the sedimentary rock still on the tops of these mountains if they've been exposed for
50 million years?
We should be more than eroded down to the igneous rock below.
The Himalayas are eroding extremely rapidly. In fact, they're eroding so rapidly that even exposure for 20 million years, like Mount Everest, half of the layers slid off Mount Everest in mainstream geology about 20 million years ago. So here we have exposure of half the sedimentary layer for 20 million years. At current erosion rates, it should have been wiped out 3 or 4 times by now.
Sure.
So why is it still there? That's the big question.
That sort of bespeaks a young Earth.
Right. Same thing for the Rocky Mountains. Why are the sedimentary layers still on top of the Rocky Mountains?
They should have been eroded away.
Yeah, they should have all been washed away because the Rocky Mountains started their mountain building, and according to mainstream geology, 70 million years ago.
Wow.
Okay. Wow. So now, we don't take that position. We take the position that this happened more recently and more rapidly and obviously more catastrophically. Yeah. And there's even evidence for that, not just in terms of what we might call ancient erosion, but even erosion right now. What's taking place?
It's obviously the continental movements have created mountain thrusts and uprisings and also deep ocean trenches. The continents have crashed into each other. That's pretty clear to all of us. We just, at least I believe, that this happened much more rapidly than mainstream geologists do.
Yes.
Now, anyone who's looked at a globe or a picture of a map of the world, the continents sure look like they'd fit together just like a puzzle piece. I mean, if you could just sort of move the eastern and the western worlds together, and we've got a picture there on the screen, and you sort of stick them together in the middle, say, of the Atlantic Ocean. So this is called Pangea.
Yeah, the continents before they split apart, it's given the name of Pangea. But the splitting apart of the continents, according to mainstream thinking, happened about 200 million years ago.
Yeah.
So, and there were people there that were observing it, of course.
Yes. So my question, though, is if it really split apart 200 million years ago, how do you explain current coastal erosion rates that are extremely rapid? Like, for example, in the Carolinas, you get rapid coastal erosion up to meters every year.
Meters?
Meters. And same thing with California.
Oh,
Florida's spending a lot of money trying to prevent erosion. Yeah. Japan is really concerned about erosion because that's all they got, that little island. And so let's just imagine, though, let's just say it's 1 centimeter of erosion on average per year.
But some areas are
much
far
more
in excess.
The average is way greaher than that. But let's just say it's 1 centimeter.
We'll be gracious.
Right. Well, what's that equate to over 200 million years?
Wow.
It's 2,000 kilometers of erosion on all sides of the continent.
Yeah.
So my question is not only
1,100, 1,200 miles.
Miles on all sides.
So technically, had it been around that long, it wouldn't be here.
Not only would it be here, is why does it still fit?
Why does it still fit together?
Precisely.
Okay.
Yeah.
Why did all the edges still match up like a puzzle? If it was
Okay,
really
so
long ago?
so it looks sort of like this, very crudely, but if they'd been eroding away, we wouldn't.
I don't know, it'd be
shape would
irregular.
change,
They wouldn't match over
it just
time.
wouldn't
But they match wonderfully, beautifully.
Right, so it seems more reasonable that there was a recent split, maybe to some catastrophic energy release that was truly massive, and that causes a rapid drift or split apart originally. But as like crashing cars, the start of the crash is very rapid, but as the energy is released or absorbed by the crashing cars slow down. And the same thing with the continents. As they crash together, they slow down, building all these mountain ranges, and ocean trenches uses up energy, and it slows down this crashing effect.
But if these erosion rates have been going on at the current rates, which is, I mean, and we've been very conservative. We've said a centimeter a year. We wouldn't expect it to look. So that looks like that happened recently.
It looks to me like it does, yes.
Okay.
And the same thing with surface erosion, or a similar thing. Surface erosion rates are happening very rapidly. At about 30 billion tons per year of sediment is being deposited into the oceans every year. And arguably only about 2 billion tons of that is being subducted underneath the continents per year.
That means one sort of being shoved under the other continent.
Right.
Okay.
So you have a surplus of 28 billion tons a year.
So let's just do that math again. You have sort of 30 billion tons of sediment per year, and then deposited into the ocean.
By rivers, you know.
Of course. And then you have rains and things. So you have, and then 2 billion of that we can account for by subduction.
Right.
So where's the other 28 billion?
Well, it builds up into the oceans, but right now we have about 10 to the 17 tons, to the power of 17 tons of sediment in the oceans. And that sounds like a lot. It's a big number.
10 with 17 zeros.
100,000 billion tons of sediment is in the ocean. But if you actually do the math, you can account for that in less than 5 million years at current sedimentary deposit rates into the ocean. So we're like, well, you know, this is, if it really
has been going on for
to
millions,
200 million years, you know, it should be filled with sediment by now. You know, a lot more. Why is there so little sediment? And beyond that, why is there any sedimentary layers left on top of the continents? Because they should all be washed into the ocean within 10 million years.
Now, good Dr. David, we are racing towards the end of our first hour, and you can see what we're doing. This may be a little technical, but stick with us. This is good information.
Yeah.
This is the kind of thing you may want to just write us and get the tape or the DVD, because there's a lot of good information here that will fortify you and sort of buttress your argument and your faith in a loving creator God. Now, we want to talk about the free offer for the evening, which is Creation Illustrated magazine. Really, really good magazine, a lot of good information, and it has really neat pictures also, but a lot of really good information. We will get this to you if you will email us at freeoffer@3abn.org, freeoffer@3abn.org, or call us 618-218, or rather 618-627-4651, 618-627-4651, and we'll get it out to you. If you are interested in sending us a question, something we're saying is piquing your mind, or if some of these big words a good doctor is throwing at us, you want to know what they mean, you can contact us, questions in the second half, live at 3abn.org for your questions, comments, or again, 618-627-4651, and we will try to get to them in the second half. Our time is fast slipping away, but I find this fascinating.
Yeah,
I truly do. I'm fascinated by the idea that my faith is backed up by good, hard science and empirical evidence, and we're getting a lot of that tonight. David?
Well, I think that some of the evidence we're sort of getting into here is as you say, buttressing our faith. You know, think of the classic definition of faith there in Hebrews. Faith is the substance of things hoped for, but what's that next word? The evidence of things not seen. We often think of faith here and evidence and science here, but the truth of the matter is that all faith rests on evidence.
Yeah.
And what we're doing tonight is we're just looking at some of that persuasive evidence. Now, it's not proof. You know, proof exists basically only in math. But what we're looking
Not even in math lately.
Yeah, that's true. That's true.
Yeah.
Very true.
But people say sometimes, prove to me there's a God. Well, what we're going to try and do is provide evidence here that says, hey, give this a chance. Invite Jesus into your heart. Ask Him to come and reveal to you the truthfulness of His Word, because the scientific evidence, the data, is there to support the Bible's chronology and perspective on the Earth, on the universe, as we've learned, and even down to the atomic level.
I am so thankful to know that God made an earth, a world, a universe that can be understood, and then gave me a mind to understand it, which is your first point, which I think is just fabulous. I think it's really good. Well, our time has slipped away for this first hour. You take a break, get a drink of water, breathe in, breathe out. We will do the same, and then we'll see you in just a few moments as we come back and talk about more really good stuff. We'll be right back. We are back, and we're having a good time. You know, you meet people that you like them instantly and immediately, and good Dr. Sean, I feel very, very comfortable with him. And
Thank you for having me.
The information is technical, but this is good stuff, and I'm glad you're here. And David is an old friend, old buddy by now, and we're glad that you're both here.
I love being here.
Yeah, we've gone through a lot, and there is yet more ground to cover. So let's go to it. We have answered the question, why believe in a little six-day creation? We've dealt with
sort of talked about that. We do have one more piece of evidence there that you're going to find staggering, absolutely staggering. I think we've actually got some images here that will come up in just a bit, but there was a paleontologist who was digging. She found a T-Rex bone. We all know what a Tyrannosaurus Rex is, many of them. And she took that bone and she sort of mineralized, or what's demineralized the bone, so that she could sort of look at the soft tissue, et cetera. And she found what we see here on our screen. What are we looking at, Sean?
She found soft tissue that was still flexible and pliable and elastic. And within
what are the little red things there?
Within that soft tissue, she found blood vessels with blood cells inside of them. And the blood cells had identifiable sequenceable protein, hemoglobin, that actually elicited specific antibody responses.
Wow.
And a lot of people initially doubted this because scientists had gone on record saying proteins, sequenceable proteins in soft tissue like this could not last more than a few tens of thousands of years, maybe 100,000 years at the maximum outset. And yet these T-Rex bones, 60, 65 million years old, according to mainstream thinking.
Yes.
And so this came as a huge blow to the scientific community. And a lot of scientists thought maybe this was contamination, maybe these structures were preserved by biofilms, modern bacteria had kind of produce these structures, but that has since been disproved, that these are actual proteins, real proteins from the dinosaur itself.
Okay, so let's get the picture here. These dinosaurs, based on mainstream geology, T-Rex sort of 60, 65 million years ago. Now you're not only a pathologist, you have a specialization within pathology which deals with blood.
Right, hematopathology.
Okay, so hematopathology. So you're dealing with blood every day, right? So let me get the picture here. If I walked out in the woods here, heaven forbid, and fell over and died, I wouldn't think that much of me would be around 65 million years later, and certainly not my blood.
And no one else thought that either until Mary Schweitzer found this discovery.
So a dinosaur falls over, it becomes fossilized, was obviously either killed by the flood or was covered shortly thereafter after it died by a flood. And, okay, fossilization of bone is okay because a bone is a reasonably hard material. But now she's looking inside and she sees, I mean, what would she have thought when she would have seen these erythrocytes, these blood cells? What would she have thought?
She thought that they were some artifact at first. And then she said, but they certainly look like blood cells. So she went and showed them to her boss. And the boss says, well, prove it wrong. Try to prove it wrong. And so she did all these tests and actually proved it right.
Wow.
And one of the tests they did, didn't you tell me something about they injected it into a rat or something?
Yeah, they injected it into lab animals, and that's how they discovered the specific immune response to hemoglobin.
Wow.
So they know it's hemoglobin.
Right.
Yeah,
and it's Tyrannosaurus Rex hemoglobin.
Correct.
Now, how does that stick around for 65 million years?
No one really has a good idea on how that can happen for that long.
And so what you're saying is before Mary Schweitzer made this discovery, the uppermost limit for how long something like that would be expected to stick around would have been
100,000 years.
100,000 years.
Right.
As the uppermost limit.
Right.
Wow.
even in mainstream thinking.
So this would communicate, from our perspective, hey, this screams, this smacks of young Earth. This thing was buried recently, just within the last several thousand years.
Yeah, it's much more consistent with a recent burial, like within less than 10,000 years. It's much closer to that now, it seems like, at least before Mary Schweitzer came on the scene, than versus, 65 million years.
And now, she's not a creationist.
She's not, and she still doesn't believe that this actually represents evidence for young Earth.
So she has unearthed evidence that. My question is, what then does science do when it runs into something that says your theories are wrong? Does it suspend its own belief system? Because we're about finding evidence, and then we're going to take that evidence and say, what does that evidence mean? Well, this evidence leads to a certain conclusion.
Well, they do say,
they don't want to make that.
They do say we were wrong. Oh, yes, we were wrong, but we must have been wrong about the preservation of proteins. It must now be possible to preserve them for 65 million years. Because you can't challenge Darwinism. You can't challenge evolution. That's
we're going to talk about.
That's kind of like a holy doctrine, which you can't really touch. But you can modify your other theories in order to fit the new evidence back into that.
Yeah.
Okay, now what about, we've looked at some of these evidences, why believe in a literal six-day creation, but what about the person who says, but they've already dated the rocks? I mean, you go dig up a rock, you pick it up, and I say, well, are there labels attached to these rocks? I mean, someone's going to be bound to be watching the program, or someone's going to show this program to someone, and they're going to say, oh, well, they've dated the rocks conclusively to millions, and in some cases, billions of years old.
Right. And in some ways, the rocks are labeled. There are radiometric dating methods that you can use to date rocks. And I'm not going to...
that gets a little technical, doesn't it?
Right. It's very technical, and I'm not going to say it's simple or that we have all the answers on the young Earth side or young life side of the equation. Now, there's some mysteries still out there for radiometric dating, but there's also some mysteries for the other side. For example, there's been fairly significant quantities of carbon-14 discovered within these old fossils, and also coal and oil as well. It's very hard to explain how carbon-14 can be there, a radioactive element, because carbon-14 is supposed to be completely gone, non-detectable, within less than 100,000 years.
And some of these fossils are millions,
tens and hundreds,
by traditional geological standards, millions of years old, and yet they still have carbon-14 in them.
It simply shouldn't be there if this is true.
Right, and also there are discrepancies between other dating methods like fission track dating and tektites versus carbon-14, and that's also technical as well, but not all dating methods agree, and the same thing is true. Dating methods can also be done without radiometric dating, at least age approximations. For example, the erosion rates is a way...
That's also a geologic clock.
Right, it's also a way to estimate age or elapsed time between physical features. And sometimes these things dramatically disagree with standard chronology.
So would it be safe to say that when we're dealing with science, there's two things? There's the facts, and then there's the interpretation of the facts, or the evidence and the interpretation of the evidence.
Or you might call it the data and the interpretation of the data. And everybody says, well, religion is about faith, making leaps of faith, and God doesn't give us all the evidence because He wants us to have faith. But for me, if you have more evidence, your faith increases.